Yes, good day, my good fans out there. Welcome to my page on social media. I am your chemistry teacher. My name is Dr. D.I. June. We have been dwelling on calculations on Avogadro's law. Let's take this last calculation for now, then we move forward ahead to other topics. Now look at it. Find the number of molecules of oxygen required to convert 6.60 dm cube of sulfur 4 oxide measured at STP to sulfur 6 oxide. Now, they are giving us information. Molar volume of any gas at STP is 22.4 dm cube, which is known as a constant. Another information, Avogadro's number, which you must equally know off by heart, 6.02 times 10 to the power 23 particles per mole. So, now let us look at it. In such a problem, there are certain things you must do first. That's why you see me giving these steps so that you can understand it better. The question says, find the number of moles of oxygen required to convert this amount of volume of this gas, sulfur 4 oxide, at STP to sulfur 5 oxide. See, it means certain amount of oxygen will react with this sulfur 4 oxide to produce sulfur 5 oxide. If you do not write the chemical equation to get that, you wouldn't get it. So it means that you must write a balanced equation between sulfur 4 oxide and oxygen as follows. That's what I've done here. This is already a balanced equation of this reaction. So if you are now following this, it means that Avogadro law is now saying that 2 moles of this gas reacted with 1 mole of oxygen to produce 2 moles of the product, sulfur 5 oxide. So now it now means that 2 moles of sulfur 4 oxide required just 1 mole of oxygen from this equation. That's what it means. Now remember that 1 mole of a gas, now the gas we are talking about now is sulfur 4 oxide. So at STP we will occupy what? 22.4. Already is given to us that the mole of a gas at STP occupies the volume of what? 22.4. That's already a known statement. It's a constant. So therefore, 22.4 dm cube of any gas at STP contains what? 6.02 times 10 to the power 3 of moles. That's Avogadro. Avogadro said 1 mole of any gas at STP will occupy a volume of 22.4 dm cube. And he's saying that the volume of any gas at STP of this will occupy what? A number of molecules, which is equal to 6.02 times 10 to the number of molecules or particles per mole. This is an information that will guide us into the problem now. So since 2 moles of sulfur 4 oxide required 1 mole of oxygen, that is from this equation now, 2 moles of this require just 1 mole of oxygen to produce this gas. So 1 mole of oxygen is required to convert this substance to SO3. Now, we are not, look at this place, we have 2 times 2.4 dm cube of this. Why is it 2 times 224? Because we said 1 mole of a gas at STP will occupy 22.4. Just 1 mole. But here we have 2 moles of it. Can you see why the 2 is coming up now? 1 mole of the gas at STP will occupy a volume of 22.4. 1 mole. But now there are 2 moles of the gas. So 2 times 224, that's what they're talking about now. Now look at it. But they're now saying that what amount of oxygen is required to convert this amount of the gas at SCP to this. Now you have seen that 2 moles of this gas require just 1 mole of oxygen. So the 2 moles of the volume, it means that 2 times 22.4 of the volume of this gas required this amount of moles. But they're not asking you if at all 2.4 will produce this amount of the gas per mole. What about this, which is 6.60 dm³ of the gas? So if 2 times 22.4 of this will require 6.02 times 10 to the power 3 moles of oxygen. Therefore, 6.60 will require what? 6.60 times the Avogadro's constant, which is already given in the problem here, all over 2 times what? 22.4. Now, if you are using calculator, you go to exponential. But the short form is that keep this as a constant. Work these two, keep it somewhere. Work these two, keep it somewhere. Divide the result of this and this, minus this one, no, forget about this one yet. And then divide by this. Whatever you have, times 10 to 23. So if you do this and divide by here, we have 0.87 times 10 to the power 23 molecules of oxygen. So it now means that this amount of the volume of this gas will require 0.7 times 10 to the power 23 number of molecules to completely convert this gas to SO3. So that is it. Like it, please comment, follow me, and also subscribe to my YouTube channel.